Hey guys, this is Michael Turallo, Expressor's Technology Evangelist. If you've stumbled across this video on our YouTube channel, you can see more like this at community.expressor-software.com, and you can look at the tip of the day section and you could review a variety of tutorials, tips, and videos that will help you get started with Expressor. Don't forget about the Quick Start and the Resources section, also available in the community forum. So this particular tip is going to be on how to use a transform operator to create a calculated field. We get that question from time to time, and I thought it'd be a good idea to post a video on that. So we're going to jump right in and get started. This is not a full-blown tutorial on how to use Expressor Studio. It's basically just to perform a particular operation. In this example, we're going to cover creating a derived or calculated field using a transform operator. So we're going to get started by selecting a read file operation. If we look at the Explorer tab, I'm in Project 1, created Dataflow 2, and you can see I have a library reference here that is looking at my shared library. Shared library is good to store a variety of reusable type artifacts like connections and schemas and types. More tips of the day will cover this in more detail in the future. So for my read file operator, I'm going to select the defined file connection, which basically points me to the location of my data file. And then we're going to create a schema. And a delimited schema is for a read file operation that basically allows you to look at a text file. Here I'll select my connection, and I'm going to select my employee data.txt. We'll give you a representation of the sample records, and you can see our headers, employee ID, employee first name, our field delimiter, and record delimiter. Please make sure that these are proper. If you're downloading Linux files, chances are that your record delimiter is going to be line feeds, so it's important that you understand what delimiters are in your file in order to use this properly. Click Next. And then since we have a header record, we're going to name all of the fields in the schema according to that header record. So we can simply select Set All Names from Selected Row. And then we'll give our schema a name. In this case, I'm just going to keep it default, delimited schema 2. Okay. And always make sure to skip your first header record. That way you get the proper data that you want to transform. So that's setting up the read file operator. Now, we have to modify this schema because we're using a delimited schema operation to read in a file. And the reason we have to change this is because everything is read in as a string by default when you read in a file. So you can see through the schema editor that there isn't any data types listed here like there are inside the semantic type. The other thing to understand is inside the schema itself, you have a left and a right section. The left section basically represents how the data is being read within the physical file. This is your external structure. And then the right side is the internal semantic type or the metadata, the actionable layer that Expressor uses to create corrective actions, attribute naming, data type conversions, etc. So understand when you create Expressor data flows, you're not mapping so much from source to target, physical source to physical target. You're mapping from a physical source to an internal metadata or semantic type representation, and then within the right operator, you're mapping from that semantic type representation to your physical target. Okay, so understand that if you're used to traditional ETL tools, this is done a little bit differently because of our semantic framework. So the first thing that we're going to do here is employee salary is the number we're going to transform. Let's say we want to create a raise amount or a bonus amount. In order to do that, we want to multiply, let's say, by, let's be generous here and say 10%. So we want to multiply that by 0.10. Well, that's got to be a numeric data type. So we're going to change that to double. Okay, so we'll automatically handle the data type conversions in here. So there's not much else you need to do other than changing the data type. Since we're going from a string within the schema to a numeric within the semantic type, we also have what's called a mapping. Now, the mapping allows you to specify specific translations from a string to a numeric data type. So localization for different languages, digits, currency grouping. We're not going to go into this just yet today, but understand that you do have finer translation of how the data is to be represented into the semantic data type. Okay, so we change it to a double, save out the schema, go back to our data flow, and then the next thing we want to do is go to our operators, go to transformers, and pull out a transform operator. So now the transform operator is kind of like the all-in-one operator that does a variety of things. It's going to allow you to look up data to enrich. It'll allow you to match data. It'll allow you to create expression functions, expression rules. It's a very involved operator that can do a variety of different things. we're going to start out simple by just creating a new derived field. So first I want to point you to the fact you have your left side, which is your downstream, and then your right side, which is your upstream. So this is what's coming in from the read file, and this is what's going out of the transform operator. We don't have anything connected to that just yet, so right now it's just listed as output. You'll notice you have your attributes, right? So they're no longer called fields after they're translated into the internal representation or the semantic type. We call them attributes. So from this point on, in between a read operation and a write operation, you're going to be actually creating attributes. So what you're due here is you'll notice that we have output attributes. Since we want to create a new one, we're going to click add, and we're going to type in, let's say, bonus amount. And then the data type for this is going to be a double. And I'm not going to go into the constraints and corrective actions just yet. We'll get into that in a little bit later. Click OK. And now we're going to create what's called a expression rule. Okay, so an expression rule is an easy way of transforming or manipulating data. And you only need to create rules for data that's going to be transformed. Everything else will be auto-propagated across. That's what these little blue arrows mean. But watch what happens when I put in the bonus amount here, and I grab in my employee salary here. Okay, you'll notice that this highlights, it has a diamond shape. That means it's a derived or calculated field. And then our rule becomes active where we can start inputting translation or transformation type rules. The data that you don't want to auto-propagate, for example, such as department ID, I can say block input. So that's just a little tip to let you know that if you don't want something to automatically go across, you just select block inputs. It doesn't mean that you still cannot use it inside a transform. I could easily create a expression rule and still use department ID. It just won't auto-propagate department ID over. Okay? So now that we have our employee salary, we want to just create a very simple transformation rule. And there is some IntelliSense auto-completion. So you have to always prefix your input variable or input parameter. We call this a rule parameter. Okay, so the rule parameter is slightly different than the attribute coming in. It's what is used within a rule. So I could actually just call this my_salary just to kind of give you an idea. And the value benefit here is that if anything changes on the physical source or targets, you're really only changing information on the edges. You're not rebuilding your rules. So that comes in handy as well. So for this IntelliSense, if I type in input dot, you can see my salary automatically comes up. And then we want to just simply multiply this by 0.10. And that's how you create a very simple calculation for a new attribute called bonus amount. And I guess let's further this one more. Let's create another attribute, and we're going to call that full name. And that's going to be of type string. And we'll create another expression rule. And we'll put full name into the output. And then this is going to be a concatenation of employee first name and employee last. And maybe I just want to represent, employee first name as F name and employee last as L name. So now we've defined our parameter rules. And now I can start creating a very simple concatenation expression, such as input.lname. Then you use two dots, which is the data script concatenation symbol. And then I want to concatenate that with a comma and a space, another two dots, and then input.fname. And there you go. So now we have our full name. So that's two simple expression rules that have been created within the transform operator. Simply just close out or minimize your rules editor. Now let's do a simple write file. Okay, and here we'll select the same output location. Now for the schema, we're just going to use new delimited schema from upstream output. We'll cover other tutorials on how to leverage existing target databases and so forth. But what new delimited schema from upstream output does is it just shows you what's available to be written to the file. So here are all of the field names, or in this case, these are going to be the attribute names that are going to be mapped to fields that will be written to the file. And we'll just call this, I'll name it write delimited schema. And then we'll give it a file name, and I'll call it my new output.txt. And quote always, just say quote as needed, and include the header record, and we're done. Let's execute this. It'll write our file. And there's my new output.txt. And let's swap over to the notepad. And here is the data that was written. And if we move all the way to the right, you can see we have bonus amount and we have full name. And then we look at the data, we can see 5,400 and then the concatenated full name. Okay, and this is the 0.10%. So for example, 500,000 times 0.10 is 50,000. And then this person's was 54,000 times 0.10, 5,400, etc. Before we conclude this brief tutorial, I did want to make mention that the transform operators can do more advanced transformations on data. Those particular transformation functions are available inside the Edit section of the ribbon menu. Just to give you a quick example, if we'll create a new expression rule that will take the plus symbols that are coming in from a phone number and replace them with hyphens. You'll notice here my inputs and outputs this time are the same. I'm not deriving new outputs. I'm actually using and replacing the data that comes in. In this particular example here, you'll notice that the rule window becomes active. I click on Edit, and then I have a variety of formulas and functions that can be used to manipulate data. And they range from string, numeric, date, time, logical, etc. String has a simple replace function. It allows me to say, for example, input dot phone, and then replace the incoming value, which is a plus symbol, with a hyphen. And that's an example of using a transform rule from the variety of functions that are available in the ribbon menu under Edit. All right, so hopefully that'll give you a good idea of how to get started with the transform operator. If you have any questions, as usual, please contact me at techevangelist@expressor-software.com. Once again, this is Michael Tarallo with Expressor Software, and I hope to speak with you in person.